Hi, Brian Taylor here, owner of Taylor Aircraft. Today I'm going to talk to you about titanium paramotors and different material use in paramotor construction and kind of dispel some of the myths that are out there. So right now, many of you are flying a titanium paramotor and think you're flying the most advanced and strongest paramotors on the market. In fact, you'll find out you may be flying one of the weakest in using a material that's incorrect for primary structure. And to give you an example, most of these paramotors are built out of grade 2 titanium. Grade 2 titanium is the second weakest titanium, and it should never be used for primary structure. It's highly corrosion resistant, and it's great for different types of piping for medical salt water distribution and things like that. And even in aviation, they use it for miscellaneous clips and brackets and components where good strength is required, but that type of titanium is easy to machine, but not meant to take a primary load. You should always use like a grade 9 or a grade 5. So if you look, even bicycles are built out of grade 5 or grade 9 titanium, never grade 2. It's just not strong enough. In fact, grade 2 titanium is just slightly stronger than 6061 aluminum. But aluminum is 33% lighter than titanium. So technically, the whole point to using titanium in an aircraft is, so the concept is titanium is almost as strong as steel in a comparable, alloy or grade, but not quite. It's almost as light as aluminum, but not quite. So how do you get the benefits, and why would you use titanium? Well, the reason is if you have to use a certain thickness of aluminum, and aluminum is 33% lighter, if you use the right grade titanium, then you're able to downsize the thickness of your tubing, maybe two or three gauges. So instead of using 65 thousandths, maybe get away with 43 or something like that, and maybe even go down from 3/4 inch to 1/2 inch and still have a strong, tubular frame. But you have to use the right grade. So the problem is, if you use a grade 2 titanium that's almost the same strength as 6061, you might as well just use 6061 aluminum tubing and up the thickness a little bit, and you could actually have it stronger for the same weight than that grade 2 titanium. So without using a grade 5 or grade 9, you're just undoing the whole purpose that titanium's there in the first place. So a lot of people know with aluminum there's different alloys, 2024, 6061, 7075, different strengths, different properties with those metals. But when people hear titanium, they just think it's titanium is titanium. That's not true. It's just like aluminum. There's different, alpha alloys. In fact, grade 2 isn't even really an alloy. It's just a pure titanium. So, so people don't realize that, and they just hear titanium and they think they're getting the best quality, highest strength. And that grade is the worst you can use for primary structure. And I'll kind of get into that. I've got a little project to show you too. And give you an example, even with aluminum. So how materials work is, let's see. So it was in aviation. When we have to form and do a repair on an aircraft, let's say it's going to be 6061 T6 aluminum, like this little strap here. Both are the same thickness. When it's heat treated, it can take a lot of load, and it's very hard to bend it, okay? This is the same material. Now, I'll get into that. So when we had to form complex parts, once it's heat treated and very strong, we can only bend it so much before it cracks. So what we would do is we would use 6061O material. It's still 6061, so that's the material composition, but the T6 or O is the heat treating, the type of heat treatment that's done to it. So in an O form, in its annealed condition, it's very bendable. It's like a wet noodle. You would never use this as primary structure on an aircraft, ever. But you can't form a part in a more brittle T6 because it'll crack. So we would take O material and bend it around, make whatever complicated part we needed. Then you would heat treat it to a T6 condition. Now you have a strong part. So what you'll see in the paramotor industry is they'll say, hey, we use grade 2 titanium. If it bends, you can bend it back in place. Well, here's the problem with that. One, in certified aircraft, you would never use a bendable, something that doesn't have a memory, a spring back to it. Okay, the whole purpose to having your hoop or arms are so if it hits something, it's actually protecting your $400 prop. Otherwise, what good is your hoop? It's not meant just to keep your brake cables from going in. Everybody's going to trip, fall, and have an incident. So you want it to have some memory to the metal so when you hit it, it springs back. The other thing is, when metal bends, it stretches. So I don't care if they say you can bend it back, it will never be straight again. It'll always have a little kink to it. And if you look at many of the paramotors on the market, you'll see the cages, they're not even round. A good 3/4 of them, look at pictures, zoom in, you'll see people flying these titanium cages, they're not even round anymore. Any little hit, bump, they bend. The argument is you can bend it back. Well, it shouldn't have bent in the first place, taking out your $400 prop, a couple $100 in cage parts, so you have anywhere between $500 and $900 worth of damage because of a simple fall. All they had to use is the right grade of titanium that would have improved its strength. So I'll kind of show you, so give you an example. 6061 T6, how they test materials, its tensile strength is when they try and pull it apart. So 6061 is 42,000 PSI. Grade 2 titanium is only 50,000 PSI. It is stronger, but using the wrong, if it's not heat treated, it's still soft. So even though its tensile strength could be a little bit stronger than the T6, it's still gonna bend much easier. So in some ways, it's actually less strong. So you're not gaining anything. In retrospect, 7075 T6 is 78,000 PSI. So almost double the strength of the titanium. So in our frame, our main frame is actually 7075 T6, where you need, your engine's mounted, you don't want any twisting and racking. So our frame, and 7075 T6 is almost as strong as steel. So it's actually way stronger than even some titanium grades. Now in our hoop, we use 6061 tubing, we use 65 thousandths, 3/4 inch. It's actually thick enough where you can drill and tap it, but it's still very lightweight. Give an example for weight, put it on the scale. This aluminum arm, I don't know how much lighter we need these things to be, but we're at 0.29 pounds. And that's one of the arms that goes here. It's light, it's strong. In fact, how strong is it? Remember, shouldn't your paramotor parts, your hoops, shouldn't they have a function other than just the net? So you're going to trip, you're going to fall. So our arms, in its weakest position, upside down where the bend is, right in the middle, I can hold my 185 pounds in any direction, and the arms don't bend. And it's only a few ounces heavier than the substandard grade 2 titanium units on the market. So just not seeing the idea behind it. And here's kind of giving examples for how important heat treating is. Here's 2 pieces of metal, okay? Both the same straps. 6061 T6, same material. So what I'm gonna do, we're gonna do a little project right here. I'm going to take the same material, and I'm gonna heat it up. So just pretend a manufacturer has to weld their titanium, and one is grade 2, it's annealed, so it's not even heat treated in the first place. And now you're gonna heat it up and weld it. So when you take and you re-anneal a piece, that's why I quenched it. So I basically took away its temper. So this is a tempered piece, and this is a non-tempered piece. So for fun, let's go ahead and connect this scale. Excuse my rudimentary practice here. Okay, this is the heat-treated piece. I'm gonna try and put my fingers evenly on it, and we'll see where it bends. So I'm at, 21 pounds as I'm bending this around. 21.5 pounds is the amount of force it takes to bend this piece. The same piece, 6061, but is no longer T6 because I just took away the heat treatment. Let's see what I did to it. And this is your grade 2 titanium. Now, I'm going to pull on it. I'm bending. I was bending it actually 5 pounds, but holding it steady, 6.5 pounds. So, roughly the heat treating, 66 or over 60% stronger. That is huge. So the point to a structure is it should have some strength to it to a certain extent, take a load and then spring back. It does nothing if any load causes it to bend. It's not protecting anything. So now on your paramotor, you've got a motor with, some of these motors are putting out over 30 horsepower. And the gyroscopic forces of the propeller, when you're doing different maneuvers, have you guys ever held a little gyroscope in your hand and tried to move it, the amount of force it takes just in your hand from a small gyro? Just think of the size of this propeller when you're manipulating it and then all the loads that are being imposed on this frame. So if you're using a material that should only be used for a backpack, never a primary structure in an aircraft, let alone even a bicycle, how can you feel safe? So kind of my point is, people are being told that they've got a titanium unit, it's super strong. I see people all the time, they'll come in, they'll take a hit, because the landing gear's beefed up, it's got some cross bracing and gussets on many machines. And of course, those areas are designed a little bit stiffer. So people hit and they'll make a comment like, thank God I had a titanium unit, it held up. But it didn't held up because it was a titanium unit, it was despite it. And the other thing is, with titanium, it has nothing to do with titanium, but as far as the manufacturing, you'll see most of these frames, sorry, let me get this out of the way. Most of these frames, where's I going with that? It's like a one-piece main frame with the gear. So one, just the weight of the gas with let's say a Moster 185, you're looking at, almost 50 pounds right there. Just moving them around, loading them in your vehicle, transporting them. I've seen so many machines where the entire frame is racked and bent because it can't even handle its own weight because, just like they advertise, it's a bendable, soft aluminum. So here you've got an aircraft structure on your back, and the frames on almost all these I see at the field have been bent, tweaked, and the landing gear's messed up, or the hoop. But there's many problems with that. So one, you'll be hard-pressed to find someone to even repair your frame. And the reason is, most welders or people that can even weld titanium won't touch it because it's an aircraft, and they don't want to be responsible for hurting you or your family. So there's a lot of people that buy these units, break apart, like, oh, I'll take it to a welder, and the welder won't touch it. And that's because it's an aircraft. So personally, and on these paramotors, doesn't matter what material, you should always have a gear that's meant to be replaceable. We're all going to trip, we're all going to fall, we're going to make a mistake. So you should have a section that you can repair without having to buy a $2,000, whatever it is, main frame to replace it. Otherwise, you got to live with a bent, racked unit. I'm telling you, look at most of the pictures on the internet. Almost all the hoops are deformed. What do you think's happened with the frame? Same thing. So what we've done is, I have nothing against titanium. I love it. We would use it too, but it's got to be the right material. So the problem is with different grades of titanium or any aluminum or any metal for that matter, let's say a grade 5 or something that's made for structure. The stiffer and the stronger something is, it can also be more brittle and it can be susceptible to vibration, cracking, and stuff like that. And that's why a lot of manufacturers choose to stick with grade 2. They just weld it, they don't think about it, they don't reheat treat it, and they just leave this soft noodle and it doesn't crack that often. So there's implications with, even with, titanium being stronger, saying you can downsize the thickness. It doesn't always mean just because something, a certain tensile strength, that you can go down, let's say 3 or 4 gauges, because now you go from what's considered a structural thickness where you could actually drill and tap and get a couple threads in there, but very strong. When you make something that's basically a thin wall tubing, now you get into other stuff, because any deformation, any crease, bend, nick, when you try and bend something, it's trying to stretch the material here and compress it here if I'm bending it this way. But if I make it too thin, then basically I lose that stretch and compression ability, and I just retain its tensile strength. But now if I make it thin wall, any little deformation, if something hits, it's just going to bend it. So there's complications. So at some point, weight, there has to be a compromise of weight and strength for safety. Now, one thing, when you talk about metal to metal, there is not, like on this frame, if you just strip at the metal, most manufacturers lie about the weight, it's how they manipulate the numbers, but you're only going to save, at best, we'll say 3 pounds metal to metal. The rest of the weight of paramotors is fasteners, harnesses, throttle, you know, just all the aftermarket parts that they put on it. I mean, everything. So if you have a paramotor that's made of, you know, substandard, tiny little hardware, versus no bushings, bearings. Say with ours, we got all bearing surfaces, 3/8 aircraft diameter bolt. So sometimes weights are in other parts, so it's not the metal. So you think you have a titanium paramotor and it's 8 pounds lighter. Well, most of these units, even the bare frame, you're well under 10 pounds on almost all frames, you know, including ours. You're within a certain amount. You can only get rid of so much before it becomes way too flimsy. But it's all the secondary components. So technically, you can build a stronger paramotor out of 6061 and adding 7075 in the right places, and it's going to be much stronger than your titanium paramotor. They need to be built out of a different grade. They need to be different thicknesses. So don't get caught up on the hype of that. People back in the day said, oh, I was happy to get rid of my old aluminum, you know, heavy paramotor. That's because back in the day, a lot of them were dual hoop designs, much thicker than they needed to be. The plates were thicker, but the structure wasn't beefed up in the right places to save weight. People just thought the aluminum ones were heavy, titanium ones were less. No, titanium is 33% heavier than aluminum. The strength comes from the different alloy. So you can use a weaker, stronger aluminum or a weaker, stronger titanium alloy. But right now the paramotors are built out of the weakest commercially available titanium out there that's never used or even allowed to be used in primary structure in aircraft. So why are you using it on yours? You're up at a couple thousand feet and you're using a material that's basically unsafe. You could see right here, just from the test, same material, just the right heat treatment. There's no strength to this whatsoever. I'm bending it like a wet noodle. Yet this is the same part, the same material, and I can barely bend it. It's all about heat treating and the proper alloy, and a combination of both. So, not trying to scare anybody, and this channel we're gonna cover different aspects, everything about paramotoring. You know, different wings, different designs, fuels, oils, everything. So, I come at this from more of a scientific point of view. This is not my opinion. You can look it up right now. Look at grade 2 titanium and you show me one aircraft manufacturer, even a bicycle manufacturer that does grade 2. And if they're not willing to put on a bicycle, how are you willing to fly that in the air? So I want manufacturers to do many things. One, you know, all these connection points, they got shackles, metal to metal. There needs to be bushings and bearings. It gives it as much as a 10 times safety factor just by putting a $2 bushing where your seat shackles go. And there's also the type of how fasteners, like where the threads start on an aircraft. The shank should always go through all mating surfaces before the threads even start. I'll get into other videos on shackles and stuff like that. But mainly right now, I wanted you to think about the materials. Don't think titanium is just the most advanced, strongest material out there. It can be if it's used right, and in this entire industry, it's used incorrectly. And that is kind of scary. So look at it. Most of them that actually show it will show it's grade 2, and it's not heat treated, and it's and they advertise about how nice it is to be able to bend it back in place. Whoop, excuse me. And I ramble a lot, so I apologize. I'm not the best at videos. I like design. But anyway, I mean, it shouldn't have bent in the first place to break your prop. So if you could have the same material that won't bend that easy and flex into your propeller, so you could actually do a powered forward inflation. So we use the materials to keep the weight down, but we could actually do a full powered inflation. Our cage is riveted and bolted. There's no flex, there's no bend. The parts are lightweight, but they can support your body. It is literally the strongest paramotor on the market. You're not going to hurt it. It's just, but don't think because it's aluminum, it's heavy. Any of the weight that we use, we're only a couple pounds heavier than, let's say, a Parajet Maverick. Any of the additional weight is the stuff that's supporting your life. This bolt is almost as heavy as this entire arm. This is nothing. You're not saving but a couple ounces if you switch to a 1/2 inch diameter, 30 thousandths titanium versus this 65 thousandths 3/4 inch. This weighs almost nothing. This bolt, but your entire life is suspended here. And this bolt, we have go through a shoulder assembly, so there's no bending load on the bolt to snap it, it's just a shear load. But this is going to support the weight of the trike, the arm, and the most advanced aerobatics you can do. So anyway, I'll get into more of that later. Just wanted to show you a little video, get started, about our Mantis and our, basically, the T1 Pro, and some attributes to that. So anyway, take care, and hope this was a little bit of an eye-opener for you. So just, manufacturers need to look at the gauge. Remember, nobody has any bad intentions. Nobody's trying to do anything. Most of these were just made by pilots who wanted to make their own paramotor and just changed the design from somebody else. And since it doesn't seem to break that often, you know, they just went with it. Very few people have looked at material gauges. Just give you a quick example. You know, even when building a sand rail or a go-kart, if you use mild steel, you'd have to use a really thick gauge, and it'd be really heavy. So how do you make it lighter? You use chromoly. You can use a third, I mean, you can knock the gauge down by 2/3 and the weight down by almost that much and have the same strength. So basically your paramotor is being built out of mild steel instead of chromoly if your titanium was considered steel. Now, you can use mild steel and you can use grade 2 titanium, but it must be much thicker to account for its lack of being an alpha alloy, basically. So, you know, the idea is that it should be built out of that alpha alloy, like a grade 5. Otherwise, you have to increase its thickness to offset that. Or you use the correct grade and decrease its thickness and save the weight. So that's just, there's no way around it. You look at any other manufacturer, any other industry, and you show me one that uses these materials. And this is an aircraft. You deserve to come home to your family. You need to be as safe as possible. And if your manufacturer doesn't understand the most basic connection techniques of using bushings, bearings, and using the wrong materials, what else is missing? What else could go wrong? What else was missed? Once again, I'm not trying to pick on anybody, but people need to consider their materials. And I don't know why it's being done in the paramotor industry, or the lack of it, and I'd like that stepped up just so everybody can, you know, feel safe in what they do. Take care. See you later.